Hello, students. So we just said that the number of even permutations is the same size as the number of odd permutations. And we know that every permutation is either odd or even. So if I add up the even permutations and the odd permutations, I have to get all possible permutations. So I know that the size of Sn is equal to the size of An plus the size of On, which is the size of An plus the size of An, which is 2 times the size of An. And this tells me the size of An because I could divide both sides by 2. So the size of the alternating group, An, is half the size of the permutation group or the symmetric group, Sn. So that tells us what the size is. So for example, for the smallest, it's kind of trivial, so I can't say smallest non-trivial, but if we have S2 and A2, what does this mean? Well, I know that the size of A2 has to be 1/2 the size of S2. Well, what's in S2? There's 2 elements. Either we have the identity or we switch 1 and 2. So this is 2 over 2, which is 1. So there's only one even permutation in S2. But that makes sense because there's only 2 permutations total. I either do this, which is even, or I do that, which is odd. Okay, let's look at the next possible case. Let's look at the size of A3. So this is saying that the size of A3 is the size of S3 over 2, which is going to be equal to, well, we know this is 3 factorial over 2. So this is 6 over 2, which is 3. So there should be exactly 3 elements in the alternating group A3. Okay, well, what are those elements? Let's think about it. So we can do this, red, orange, yellow. So I know I have the identity. So let's write that. A3 is equal to the identity. Now, I know right off the bat that I don't have any of the odds. So I don't have 1, 2. I don't have 1, 3. And I don't have 2, 3. There's only 2 permutations left. That's 1, 2, 3, and 1, 3, 2. So it's easy to just count out the odds. And of course, we can write these as an even number of 2 cycles by taking 1, 3, and 2, 3 and putting them together in that fashion. Or I guess depending, we're writing from left to right, so 2, 3, 1, 3 would be the way I would do that. And for this one, 3, 2, 1, 2. Okay. One thing to keep in mind is whenever we're doing this counting, and we've been doing it for a long time, keep in mind that we're not dealing with disjointness in any way. We haven't been. We haven't been for many videos now. We're not talking about disjoint permutations when we talk about evens and odds. We're just talking about even number of 2 cycles or odd number of 2 cycles. Okay, so we know what the permutation group A3 is. What about the permutation group A4? So the size of A4 is going to be, oh, and we're finally looking at what the elements are in these ANs as well, which is nice. Though these groups get kind of complicated, and trying to sort of categorize all the elements in general is not going to be an easy thing with a very short result, depending on what you mean by categorization. But okay, so this is S4 over 2. S4 has size 4 factorial, which is 6 times 4, which is 24. So A4 has 12 elements in it. And what are these 12 elements? Well, one thing we might notice is, hey, we had these 3 cycles in A3. They're still going to be in A4. Because I could do those same switches in A4, and it's still going to be even. If I do this and this in A3, A4 doesn't care if you have this like green guy hanging out there. Green cube doesn't know what's going on with the rest, minding its own business, just sitting there by itself. So these are also going to be in A4. A4 is equal to, we have the identity 1, 2, 3, and 1, 3, 2. And of course, any other 3 cycle is also going to be in there. So I have 1, 4, 3, and 1, 3, 4. I have 1, 2, 4. and 1, 4, 2. And I have 2, 3, 4, and 2, 4, 3. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means we're missing 3 things. Okay, so what are these 3 things? Well, think about things that we can get to from an even number of 2 cycles. We can get to each of these with a pair of 2 cycles which are not disjoint. And I probably just gave it away. Stop and think, what are the missing permutations here? Pairs of 2 cycles which are disjoint are going to be in A4, right? So what are those? Well, we have 1, 2, 3, 4. We have 1, 3, 2, 4. And we have 1, 4, 2, 3. And that's it. Those are the only ones. What about 2, 1, 3, 4? Well, that's here as well. So is 4, 3, 2, 1, right? We can write this in many ways. These are disjoint, so I could put either one first and either one second. And I can write this in 2 ways, and I could write this in 2 ways. So I have 2 choices for how to write this, 2 choices for how to write this, and I have 2 choices for which one goes first. So I can write this in 8 different ways, but it's still all the same permutation. So 2, 1, 4, 3, that would be equal to that. So nothing else. Nothing else is in here. And these are the 12 elements of A4. Now, by the time we get to 12, that's getting to be a lot. What can we do? What else can we do here? Well, we could sort of ask what's not in A4. And you might say, well, why would you ask that? It's not even a group. It doesn't contain the identity. You would be correct. But there is a reason for this, because we are, at certain points, we're going to want to consider what the odds are, maybe simply because they don't behave the way we want, and we want to not think about them, and we want to be sure they're not somewhere. But in any case, what would the odds be composed of? Well, let's think about this. We would have all the single 2 cycles, right? So the odds, and I'm going to stop using ON because first of all, I don't like O's for my notation because they get mixed up with zeros. But also, ON has another meaning even inside group theory. So I'm going to stop that. I'm just going to say the odds. So what are in the odds? Well, we have single pairs, AB. I'm just going to use a brief notation here. So how many of these do we have instead of listing them all? Well, you might say I have 4 choices for that, and 3 choices for that, right? So that would be 12, but it's not going to be 12 because 1, 2 and 2, 1 are actually the same permutation. Well, maybe we will list them. Maybe that will make things a little easier. So what I could say is, hey, I have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. And what was that? Well, we had 4 times 3 over 2 possibilities because we had 4 choices for the first element, 3 for the next. But there's each one of these has 2 different ways of writing them. So I have to divide by 2 so I don't accidentally count anything twice. So what are the other permutations which are odd? Well, we've left out the 4 cycles. And how many different 4 cycles do we have? Well, let's think about that. We could always start our 4 cycle with a 1 if we wanted to, right? Because we could put 1 first, and 1 does appear, so there's no question about that. And then what could I do next? Well, I have 3 choices here, 2 here, and 1 here. So that means how many choices are there going to be? Well, there's going to be 6 choices. So we had 6 2 cycles, 6 4 cycles. So what we've done here is not just talk about the alternating group. We've sort of broken down S4 into bits, right? S4 has our even permutations, which consist of the identity, the 3 cycles, and the disjoint pairs. And we have the odds, which are going to be the 2 cycles and the 4 cycles. And this is actually going to be useful whenever we want to actually get our hands on the symmetric group moving forward.